most confusing thing about this lesson is the word even, because when you think of even, you think of 2, 4, 6, 8, 10, 12. I don't know why we use this word to talk about functions, but I will explain the best way I know how. I do know how it's related. The function x squared we're going to learn is even, and we know that 2 is an even number, but not all even functions necessarily have that attribute of having an even power. Okay, let's take a look at this slide, and I'm going to plug in -3 into the function x squared. And what happens when you take -3 and square it? You get -3 times -3, which is 9. Okay, now what happens if I plug in +3? I get what back? Positive 9. Let's look at if I plug in -5, I get positive 25 back. But if I plug in 5, I get the same number back. And so,
You always get a positive number.
okay, and you get the same answer whether you plug in a negative or positive, right? That's what I want you to see. As it turns out, when that happens, when you plug in a negative and a positive, and it works for every single number, and you always get the same answer back, that's called an even function. Okay, so this is the first example. Make sure you write this down, because this is what you're going to be doing on the worksheet. Now, in order to prove a function is even, you have to prove it for all numbers, not just 5 and 10 and 3. It's got to be true for all. So make sure you write these steps down, because it's very important. So we're going to prove why x squared is even. We're going to do it right now. The question we're asking, does f of -x equal f of x, no matter what? A question mark over the equal sign, that's literally asking, are they equal? Okay? I think it's a pretty good way of writing that. Pretty intuitive, right? If you put a question mark above an equal, that means does it equal? Put a question mark above greater than, does it mean is it greater than? So anyways, first thing you're going to do, again, it's important you write these steps down, is to plug in -x. Now we've evaluated functions, and we know that whatever's in the parentheses over here has to be in the parentheses over here. So every time there's an x, you're going to replace it with parentheses -x. In this case, there's only one x, but on many occasions, there'll be multiple. So every time there's an x, you'll put -x in. All right. Step 2, you're going to simplify that. I did a lot of work there. You don't need to do all that work. I think everyone in here understands that -x squared is just x squared because the negative goes away, okay? If you don't understand that, you can take a look and see why that's true. We have two negatives which make a positive, and then x times x is x squared. Okay, so just to reiterate, we're plugging in -x, and then we're simplifying for step 2. Step 3. What we're going to be doing for step 3 is we're going to take what we got here and comparing it with the original function. Okay, here was the original function, and here's what happened when we plugged in -x. What do you notice about them? They're the same. When they are the same, they're even. When they're not the same, they're not even. Exactly, yeah, it's just a word, okay? All you're doing is seeing if you get the same answer back. Regardless of what the function looks like, if you get the same answer back as when you started, that makes it an even function. Okay, so that leads us to the simple definition of what an even function is, and that's when f of -x equals f of x. All right, example 2. So you're going to see that perhaps it doesn't necessarily have to have, an x squared or an x to the 4th or an x to a 6th for it to be even. So the way we read this function is f of x equals 3 minus what? Good, absolute value of x. The bars around the x mean absolute value. Good.
You don't even have to do any work.
Some people Some people might get thrown off by the fact that there's a negative here, but you're right, and I'm going to explain. There's a reason I'm doing this one, because you're right, it's pretty obvious that it becomes positive, but let me just explain the mistake you can make, okay? So still for step one, you're going to plug in negative x. So the mistake that you might make is, well, that's two negatives, that makes it positive. No, it doesn't, right? You have to do what's inside the parentheses or absolute value first. That kind of acts like parentheses. So what we're going to do is take the absolute value of negative x, which, like she said, okay, listen up, guys. This is important. The absolute value of negative x is not x, okay? I hear this every year by more than half of my students. The absolute value of negative x is not x. It's absolute value of x. The only thing that goes away, okay, is the negative sign. The absolute value bars do not go away. If you think about it, let's say that x, let me actually do an extra slide here because this happens every single year. Let's say x was equal to -3, okay? And let's just write this expression back. Absolute value of negative x, okay? If I plug in -3, I get absolute value of -3, right? Which just becomes 3, right? So I can't just write x. It's not equal to x, is it? It's equal to the opposite of that. It's equal to the positive version. That's why you can't just write x out. Anyway, the bars don't go away. It remains absolute value of x. The only thing that goes away is the negative. Okay? So when you simplify, you get 3 minus absolute value of x. Now, is that the same as what we started with? Yes or no? Yes, it is. Okay? So when you compare the two, they are the same. Therefore, we can say it is even. Remember, the definition of even is f of negative x is equal to f of x. Okay. Example 3. Okay, this one kind of looks even because of this 2 right here, right? But we're going to see just by doing the steps whether it is or not. Okay, so you can't just always look at it and say, yes, it's even, or yes, it's not. So step 1, you're going to plug in negative x. Step 2, you're going to simplify. Now I've written that's all you can do. You can't raise a negative x to an even. This was actually an even root. We talked a little bit about the fact that that would be the square root of negative x. Okay, the reality is, for this particular example, you cannot simplify it anymore. Okay, again, if you wrote this in radical form, it would be the square root of negative x. That cannot be simplified. You can't pull the negative out or anything like that. Okay, so if you can't simplify it, that means that when you compare the two, here's f of negative x and here's f of x. They are not the same. So we're going to put a non-equal sign right there. Okay, so if they're not the same, then we say no, it's not even. Any questions on that? So literally you're just looking to see if they're the same. If they're not, then that's not even. Okay, how many of you think this one's going to be even? Nobody? So you guys think it's not even?
I do, because like 2.
Okay, so we got a 2 on the bottom. Okay, there's a -4, and then what would be the power for the top? Well, there's one you can fill in. 1, yeah. So that's an odd power on the top and an even power on the bottom. We'll see what happens. I'm going to plug in negative x for every time there's an x. So plug in negative x there and plug in negative x there. So this one has 2 x's. So you're plugging in both or the top and bottom. Make sure you put it in parentheses. Okay, so you've probably already seen what's going to happen here. What the bottom is going to simplify to just x squared minus 4. The top is just negative x, okay? So there's going to be a slight difference between the two, right? So even the tiniest of differences, g of negative x, there's a negative x on top. G of positive x, there isn't one. They have to be exactly the same, okay? Once you simplify them out. If there's a slight difference, then it's not even.
Simplify this, would there still be the 2 at the power? Like, would the power still be 2?
Yeah, because we just did negative x to the second power, which becomes positive x squared. Are you talking about dividing? No, you can't divide.
No, at the end, would the equation still have a power? Like, would x still have a power even though we already used it to figure out? Does that make sense?
That's it for that one. One more. All right, we have x to the 4th minus x to the 2/3 power. Now, the 2 in the top means we're going to be squaring whatever we plug in. So keep that in mind. The 3 is basically doesn't mean anything in terms of this problem. So we plug in negative x. And then we're going to simplify. Now, I know you guys, some of you aren't too comfortable with this, but so I'll explain it real quick. The bottom of the fraction becomes your root, whatever that is. If it's a 5, then you put a 5 there. The top of the fraction becomes your exponent. Okay? And then again, going back to the negative x to the 4th, it's still x times x times x times x. The only thing that happens is 4 negatives make a positive. But if you were to simplify x times x times x times x, okay, that doesn't simplify to x. That simplifies to x to the 4th. Okay. So anyway, yeah, the second part, you've got a negative x squared, which just becomes x squared. And then when you reconvert it back, you should have the same power left over. It should be x to the 2/3, which you started with. The only reason I converted it was to show that negative x squared is equal to x squared. Okay? So the question is, did we end up with what we started with? Yes, we did. Okay? So normally, I will say this, if all the powers are even, including the numerator of the fraction, and it's one single expression, then yes, your answer is going to be even. So that would be maybe a little shortcut that you could follow. I did shorten the